like this very much that I had a PhD student created a new society, and thank you very much for this. And I think we will have many more of these kinds of events with this society. My congratulations to you for this. And well, then I will go to my keynote lecture, ladies and gentlemen. Bern is an even smaller city of Switzerland, but it's the capital of Switzerland. And it's directly situated in the Rösti-Graben, which he showed us before. And we are in Bern, we are bilingual. We have two languages, we have French and English, and French and German. And everybody needs to speak English anyway in scientific sessions. And I have to admit, since I always have to speak German and sometimes French, the English did not become really better at that time during my time in Bern. I've been at Bern since 2010. Before I have been at Freiburg in Germany in a similar position in the Forensic Institute, and we started actually working on PEth already in 2009 in a collaboration with University of Tübingen, Ulm and Heidelberg, where Heidelberg and Tübingen and Freiburg had the main part for the PEth analysis. And actually that was the beginning for me thinking about PEth, but there has been much more work before that time. For me, PEth was a new biomarker, and I will come back to that later. Now, why are we thinking about PEth? We have about 3 million deaths due to alcohol use or harmful use of alcohol per year. And I calculated for this for a certain time actually. For the time of the COVID crisis, it's about 2.2 years. We had worldwide 6.6 million deaths. And when you compare this now to COVID numbers, we had registered deaths, 6.3 million from COVID-19 in this same time. So alcohol has about the same number of deaths in the world. And this gives us good reasons for more further scientific investigations in alcohol biomarkers and their applications. And the most important thing is actually you want to reduce the harmful alcohol consumption. And the reduction of the alcohol consumption, those are the applications of all the markers. In the abstract book, I wrote a lot of applications, which I am not going into detail today because I want to give you an overview about PEth. Well, PEth has been cited in the literature in the last few years as a new biomarker for alcohol consumption. But I think when PEth is called a new biomarker, then I would be probably a young scientist. And I have been a young scientist 17 years ago, but not anymore. So, because PEth is not so new biomarker. It already has its 40th anniversary. Actually, it was extracted at that time, 40 years ago, the first time. And some applications have been published, and also LCMS is winning the field against other methods since 13 years. And we have Dutyrated Standards, and we have tried blood spot analysis already since 11 years. So to begin at the very beginning, actually this was a paper in 83, in 83, but actually it was already submitted in 82. That's why we have the 40th anniversary this year. And this was done by Christa Alling. Some of you might know Christa Alling. When he was working in Sweden, maybe he was working all the time in Sweden.
Yeah.
Is he still working in Sweden?
Lund University. Unfortunately, he died a couple of years ago.
Okay, so he was in in Lund, and this is crystalline. And at that time, detection of PET was not so easy. It was more or less state of the art to use thin layer chromatography. These thin layer plates, the smaller ones, the HPLC plates from Bern, for example, and use staining with, for example, agents like copper acetate. And there's also a picture of Lena Gustafsson. She's still on LinkedIn, so she's still active. And that's how the PET analysis looked at that time. PET was not identified as PET, it was just X. I always use X if I don't know. If I need a variable, I always use X2. Maybe because I'm also a little bit older. So at that time, all the lipids extracted from some rat organs were separated by thin layer chromatography. This is one plate, this is the other plate, I guess. And here are some standards also. The reference material has been maybe on another plate, so they identified by retention indices. And finally, they found in rat brain here and in kidney, as well as in liver, not so much in muscle. They found a lipid which was not yet identified when the rats were intoxicated with 3 per ml of alcohol. And here some of the rats were sacrificed after certain times, after 1 hour, 2 hours, 4 hours, 8 hours, and 24 hours, ingestion of alcohol, or donation of alcohol. Then they had, after 2 hours, the X is showing up. After 4 hours, it's still present, and after 8 and 24 hours, it's not detected anymore. And when we now think about our further experiments, we can really think about we should also see something like this, maybe in humans, after ingestion of alcohol. So what else did they already see at that time? They analyzed also the fatty acid content of this X, of this lipid, and they found a fatty acid composition which was determined by the diet given. That means, for us, that's a factor which is important if we have, in the end, the saturated or non-saturated fatty acids in our X, which is produced after alcohol consumption. So this was 40 years ago. Well, then, a year later, that was really fast. Again, Chris Darling, Lena Gustafsson, etc. They identified X. How did they do that? They used phospholipase E from PEth-NET, and then they ran several experiments. They used HPTLC, headspace GCMS in 1983. That was brand new. The company, it was actually older, but it was then commercially available at that time. And they also made experiments with radio-labeled ethanol. And just to show, they used the following reaction. They used phosphatidylethanols and phospholipase E, and the product was phosphatidic acid. This is shown here. This is the phosphatidic acid. And then they used phosphatidylcholine with ethanol, and then they had 2 products, especially the X showed up again. And when they took the X and incubated it with phospholipase D, they produced phosphatidic acid and a little bit of remaining X. So that was the reason why they thought, well, it's a reaction catalyzed by phospholipase D, and then they looked at ethanol and the deuterated stable isotope, the radio-labeled ethanol aspects always have the stable isotopes in mind, so sorry for that. the radio-labeled ethanol and did some more experiments, and they found out it must be PET. So the X was converted to PET in 1983 already. That was the 83, so it was 39 years ago. Now, 34 years ago, there were investigations done by Professor Müller. He was in Wisconsin, and he did investigations with adults who were alcoholics and adults who came from families who were alcoholics. And actually what he found there, that he said there are factors which influence the generation of PET. And these factors, may be related to an upregulation of the PLD activity, which for a higher yield in PET concentration. Well, the factors are prescribed. At that time already there was this TBA, which induced an activation of PLD. And this is important because nowadays when we want to interpret the concentrations, we also have to think about factors influencing the formation of PET. There was also an article in Russian. Probably nobody read it because it was in Russian. And it was also thinking about alcohol pathology induced by some effects of this special kind of lipid. So this is more a paper dealing with function of membranes and problems induced by alcohol consumption through the membrane irregularities. Well, going further on, jumping to 25 years ago, that was the first study where blood phosphatidylethanols was used as a marker of alcohol abuse. Especially they were looking at people from withdrawal treatment, and what they found is that they can detect, and this is actually the day of the treatment and the blood alcohol, the blood PET concentration, and you see they could detect something for about 30 days in the withdrawal therapy already 25 years ago. And how they did it, actually it was similar as before. They isolated the lipids from blood. Now it's not red brain or red kidney, now it's human blood. And they isolated it, and then they had on the first day a bigger peak or spot for PET, and this is decreasing second day, third day, ninth day, disappearing on the 21st day. They still have a kind of a spot here, and those who have never seen a Carmack scanner, for example, they might not know how this is done. The detection is by a scanner of the TLC plates, and that was the possibility for them to make it semi-quantitatively or quantitatively. So they isolated the PET by TLC, and then they used the scanner for detection of the quantity. 30 days, that was quite a long time at that time, and 25 years ago. Okay, 24 years ago, they started with human drinking experiments. Actually, this is my favorite, human drinking experiments. I like this very much. We did a lot of these drinking experiments ourselves for ETG and ETS in Freiburg, and when I changed to Bern, we did also a lot of drinking experiments for PET. So the first drinking experiments were done 24 years ago, so this was in the last millennium. And again, in the group of Squirstalen, and they compared it with other markers. And at that time, they used HPLC with evaporative light scattering detection a detector costs like 25,000 euros from H&M. I know that because in Heidelberg they also bought one of these detectors, which was actually in vain because they also had Alzheimer's in 2009 already. So actually this was a peak. I'm not so sure if this is correct. This should only be 3 nanograms or something like that. It says 5 micromolar or something like that. 5 nanomole of PET here in this peak. I'm not so sure if this is correct, but well, we have to believe what they have published. So it's a very nice peak. So the sensitivity is good enough for detection of PET in alcohol withdrawal patients. And actually this run usually, I know from our results from Heidelberg at that time, the run was 45 minutes or so, so it was not high throughput analysis at that time. Well, they gave the males about 47 gram of alcohol, women got only 32 gram of alcohol, vodka as a mixed with Diet Coke with 500 milliliter. So this is not so bad to drink this, but they drank it in 15 minutes, which is not very nice, but it helps to resorb the alcohol pretty fast. And then they took blood half hour, 1 hour, 2 hours, 4 hours, and on day 1, 2, and 5. This reminds me very much of our last experiments when we also took the blood in similar ranges after drinking. So it was a single dose experiment, but they couldn't detect PET. So this gives about 0.8 to 1 per mil. Alcoholization if somebody with 75 to 80 kilograms drinks 47 grams of alcohol. So after 1 per mil, they did not get any detection. But then they had some vaudeville students from a theater, and they had some performances, and between the performances they did not have any performances, so they could drink a lot. And they took these students, and they did not only drink up to 47, this would be here, 50 gram, but they drank up to 200 grams of alcohol. This is equal to 4 times more. And they drank it on day 15, 16, 17, 18. They really had a big party, I guess. The first days were going, they drank a little or more, and then they had performances, so they had to stay clean. So after 20 days, they investigated the sample also here at the beginning and at the end of the last drink and some days later, and they found 1 to 2 micromole per liter PET. So this is about 700 to 1400 nanogram per mil. And this is total PET. This is not PET 16,081. This is total PET. The 16,081, the major ones, is about 30-something% of the total PET. So in numbers with the 16,081, that would be about 300 to about 600 nanograms after this long-term drinking experiment. So 17 years ago, they started to make a better HPLC ELSD method, going down with the detection limit to about 150 nanogram of total PET, which is equivalent to approximately 50 to 60 nanogram of the C1681. So this is pretty good method already, and this was published in 2005 by Steiner Adotia, whom we also know, some of us. And a couple of years later, there was the first publication of LC-MS and MS-MS on PET, used for blood PET determination. This was for detection a sum of 9 PET analogs. We call it them, since some years we call it analogs because it's not a real homolog. Homologs have just always the same group which is multiplied in the molecule, and here we have some differences in the grouping because of the oxidation state. So we call them PET analogs. Those were the major PET analogs they found, and this was published in 2009, so it's about 13 years ago. Well, in the same year also the group in Frable, Heidelberg, and Ulm, the three groups were working, that's why there are so many authors, were working on PET, and we also published a method for LC-MS at the same time in Journal of Mass Spectrometry for the PET homologs. And further on, we detected all together with all the MS experiments we did, we detected 48 analogs of PET at that time. A year later, that was published by Heike Gnann. Actually, Heike Gnann also was a PhD student of mine. So, from the Hellander group, or from Sweden, this no, this was not Hellander group, that was von Prester-Elling's group in Lund. They finally published their data from 2006 to 2011, which they had collected with HPLC ELSD, and that was probably the last time when they really did a lot of work, and they had in the clinical applications, they usually had used CDT, and then they did the PET, and in the end they decided after 5 years, after ELSD had been implemented with a lower detection limit, they decided to go to LC-MS, and actually they also decided, well, we don't want to analyze CDT anymore, we like PET much more at that time. So 11 years ago, also the Dutyrated Standard for the internal standard for mass spectrometry was introduced, and this was done in the group in Stockholm of Hellander. And what they actually did, they synthesized deuterated internal standard by the phosphatidylase reaction with deuterated ethanol and phosphatidylcholine. So they could then use the internal deuterated standard, and that was a good idea at that time, because then the accuracy and the precision of the measurement becomes much better, because we always see with all the lipids, we see suppression effects and these things which are for electrospray ionization can be a real problem. So they could also lower the limit of quantitation to 70 nanogram per milliliter about 11 years ago. And they analyzed, they said the PET has 36, the 16081 has 36% of the total PET, the 16082 has 26% of the total PET. Well, I just want to remember you, 40 years ago, somebody said it depends on the diet of the rats, maybe also on the diet of the humans, what comes out here finally. So, again, 11 years ago, the same year, that was a publication from Andrea Faller. She was a PhD student of Gisela Skop from Heidelberg at that time. Now Gisela Skop is working at the FTC in Munich, where also Frank Mushoff, our board member, is working there as the boss. So Gisela Skop is now actually retired, working in the FCC, and Andrea Faller did this PhD thesis on dried blood spot, and I think this was the first publication I found on dried blood spot. She introduced dried blood spot analysis for PET 11 years ago. So now I just want to go on with some publications of our group, because I like drinking experiments, not myself, but I prefer to other people to drink, and we just take the blood and analyze it. So this was a drinking experiment over 5 days after some abstinence before these 5 days. And the drinking experiment consists of, you have to drink to 1 per mil. So 1 per mil is actually, maybe you remember, it was the same what they could not detect 25 years before. But then we had the blood alcohol concentration. This was amazing. This was the 1 per mil we calculated, and there were some who were very much higher. This was an elderly guy, 75 years old, a pharmacist. He had 1.8 per mil or something like that. This was amazing and led to another publication, because when you're getting older, the water content of your body is decreasing, and then the calculation with Wittmark and some resorption deficit is not correct anymore. So that was the problem with older man who has had a very high level of alcohol. He had to quit the experiment after the first day. The others went on drinking on the second day, 1 per mil, on the third day, the fourth day, and the fifth day. So, and actually, these are the days 1, 2, 3, 4, 5, and the PET values. So after 5 days, they had the last drinking day, and then they had to be abstinent, and then we found PET eliminated. The levels are very different. Also, the alcoholization was a little bit different, but in the end, we could detect many days. We could detect it, and the levels reached here were above 50 still. So these curves could have been a little bit longer. So with 5 days, the maximum reached PET concentration was 225 nanogram per mil for 16,081. But this guy, for example, he started at 100 already, and this is, meanwhile we know that the abstinence of 1 or 2 weeks is not enough for many people. Our last experiments were with abstinence for 4 weeks, and then drink to 1 per mil. This is pretty hard. Okay, 225, but there were also 4 volunteers. We did not publish this very highly ranked, because it's just in the dissertation, which is found on the internet of University of Frable. They drank until 10 days. So the guy who started with a higher level already, he even reached a very, very high level, which could be maybe explained that he was not abstinent all the time. Maybe he has some kind of enzyme induction and produces a lot of PET, or a lot more than the others. So the others who started at lower levels, this is already first day, yeah, they reached up to 250 approximately. And after 30 days, we could still, so 10 days drinking plus 20 days, we could still detect PET. The maximum volume of this guy was 540 nanograms of PET. I think we can imagine that people who drink much more and withdrawal to come to a withdrawal therapy, then this time is not only 20 days. And we have seen that before, also from Krista Elling's experiment, that it is much more than 20 days, even with the higher, it was 28 days, even with the higher LOQs. So 5 years ago, we started another single drinking experiment at Bern, and they drank, that was Alexander Schröck, another PhD student, and they drank to 0.18 gram per kilogram, and then we had 16 volunteers and 3 weeks of abstinence, but for 3 weeks we are still not enough, because before these three weeks it was carnival, and for carnival here in Germany and in Switzerland, people tend to drink a little bit more. So after the 3 weeks, they were not clean. So we had to skip the data of 7 of 16 people, because they were just not clean at the beginning. Well, the others, which were clean at the beginning, they showed then concentrations between 35 to 122 with 0.8 gram per kilogram. And this has been published, these data. Also, the 16082 has been published. It was going up to approximately 100, the maximum. But we also see quite a bit of variation here. And the BAs, the blood alcohol concentrations, they were not so variable in these experiments. So the variation is becoming more dramatic with the PET. Well, in 2019, we had this, I just want to summarize a few of Mark's work. What he did in his thesis, he looked at withdrawal patients, and we had detection of PET for more than 60 days. And the elimination half-life, we found that there are different elimination half-lives. So terminal half-life is around more than 10 days. When you look closer at these curves, it can also be about 15 days. So at the beginning it's faster, and at the end we have a very long terminal half-life. And these experiments were actually done to find out if we have a possibility to also see relapses. Relapses in withdrawal treatment, you would now expect that one of these dots would go up a little, at least a little, like 100 nanograms per milliliter or something like that. And actually that's what we saw here. We saw here a patient who, well, he had already some higher levels on day 22, and then another higher level here, and also here. And actually, we also had a few samples for urine, ETG and ETS, and actually in this one, we also had the ETG and ETS and saw it with urine. And with the PET, we have just a longer detection window. With the urine samples, we have only a smaller detection window. So we found a relapse also in this curve here. And there was one candidate on day 42 of the withdrawal and maintenance treatment. It was Christmas, he began to drink. You can see this here in the PET values, and the dotted lines are the ETG and ETS values. So this subject, we could clearly see he was already down below 50 nanogram per ml, and then he got up to 250 by several times drinking more than probably 1 per ml. We don't know exactly how much he drank. So there were other studies at the same time, so everybody is doing practically the same thing. That means actually if we wouldn't have done a study, somebody else would have found it out, which is good to have something like backup. And we also think that we should go on with these procedures, that also experiments should be done in parallel, which is also working. And and this Michael Götter, Anders Hellander, the analyses are always done in Dessau, I think, with Olaf Beck also working in Dessau, in Michael Götter's lab. And they they postulated that one value of PET is never enough to find out what the quantity of alcohol was. So there's a whole big selection of more topics which are coming up during the conference today, but also by some more publications. The thresholds harmonization beginning in 2013 in Sweden, now finally with Wolfgang interpretive guidelines for thresholds. Then we have these radioisomers of PET, which was published by Wolfgang and friends. And we have more automation, we have hematogrid corrections, and we have multiple applications of PET. And my time is over, so that's my last slide. I don't have any conflict of interest. Also, some people wrote down in PEth-NET that I am Mr. PET. It's not actually true, I'm not Mr. PET, but I have no conflict of interest. And this is actually one year which I did not find anymore. This we found 2010 when Heike Knang made her PhD thesis, but on the searching for another alcoholic beverage, we found this winery in Germany. They have PET wines. If you need something special, you can order them from Germany. Thank you very much. Thank you very much. Thank you, Mr. President.